Do you have any problem for this?
Let me check.
Have you finished all of them?
No, 11.
Oh, so you talk about the problem 11. Right. Then just 11 anymore?
I mean, 11 was the biggest one.
Oh, okay.
Is array there?
Still not, but it's okay. We just start. Let me see. Yeah. He's still not online or come to my address. Okay, let's say 11 table 1. Where is table 1? Oh, table 1 is here. Oh, okay. Ray is logging now.
Okay.
Good evening, Ray.
Hello, sorry, I was having some internet problem.
Oh, no problem. We just start. Yeah, when we go to homework, chapter 8 test, Neil mentioned the problem 11. So
Yeah,
do you have more problems you want we go through?
maybe, wait, let me see. Maybe problem 3. I'm a little bit confused on that.
Okay, so let's do 3 first. Then go to 11. Graph the function this for one complete cycle. Okay, this is, yeah, I suppose we'd better make sure we are okay with it. Yeah, if you are not so familiar with the secant, you can change it to what? Sine or cosine. So cosine, right? So this is half 1 over cosine 4 pi x minus 1. All right? Yeah, now let's talk about something. For example, what's the domain for this function? And even we can go to the range, right? Neil, in your homework, do you show what's the domain for this?
Oh, I didn't really.
Yeah, if you don't really did it, now you can think about it. What should be domain here? Ray, any idea?
Wait, let me see.
Okay, let me talk about it. Of course, we need let me circle. This cannot be 0, right? Yeah, let me write here cosine 4 pi x minus 1 cannot be 0. Yeah, let's just find this equal to 0. Then what should be x, right? Okay, then think about it. If this is 0, if we want a cosine equal to 0, then 4 pi x minus 1 should equal to what?
it has to equal to either not pi over 2.
Could you write it? Yeah, I know. For example, it means pi or half pi or
Like
anyway.
this?
Yeah, you exactly right it.
I'm not too sure.
Name of,
Just guessing.
oh yeah. This is just the two of them. We know if using the unit circle, we know cosine means the x coordinate, right? If
Yeah.
x coordinate equal to 0, suppose it's either here or here, right? So that means that you can do it like this. 2 pi, oh no, half pi plus k pi. K just, k is any integer, right? Correct?
Yeah.
Mm. You say when k is 0, then it's just half pi. When k is 1, then it's 3 pi over 2. When k is 2, then again it's like this, half pi. Means after full circle, then half pi. Yeah, anyway, this is means the general for this, right? Then keep going, we have 4 pi x equal to, I write k pi first, plus pi over 2 plus 1, right? Then x, both sides divide 4 pi, so we have k over 4 plus, pi and pi cancel, so 1 over 8 plus 1 over 4 pi, right? Then if we talk about domain is x is any real number, but except this, right? Except this, leave it here. Then who can talk about the range for this function? Any idea about its range?
No.
Okay, we know cosine, the value for cosine is between -1 to 1, right?
Yeah.
Inclusive. But because the domain, so cosine cannot be 0 here. Then for this cosine, it's just, yeah, let me just write. Then suppose it's -1 to 0, but not include 0, and then 0 to 1, right? Now, if we take the reciprocal, suppose when here is 0, yeah, anyway, when take reciprocal, all of this should go to, you say -1 take reciprocal, just -1. A number close to 0, but it's negative. Then after take reciprocal, it's go to -infinity. So that means that -infinity to -1. Then, oh, let me close my, then 1 to infinity, right? But we need a time half. Yeah, let me circle it. We need a time half. Then suppose the range is -infinity to negative half inclusive and half to infinity. This is the range, right?
Yeah.
Mhm.
Now let's talk about the. Do you think what's the period for this function for y?
The period.
Mm-hmm.
Um,
Suppose it has same period as cosine of 4 pi x minus 1, right?
yeah.
Then what's the period for this cosine? Yeah, let me box for you. What should be its period? Period normally we use the letter t. So per the formula, it's 2 pi over b, right? Who is b? B is this 4 pi. So 2 pi. Oh, sorry. Let me write it better. 2 pi over b. B is 4 pi. So suppose its period is half, right? So this is some basic analysis for this function. As I don't have more space, could you guys screenshot this? Then I'll erase all of them.
Okay.
Okay.
Yeah, remember some basic information. Period is half. X cannot be this. Yeah, anyway, we just remember cosine cannot be 0, then it's enough. Now, okay. Now let's try to draw one cycle. Yeah. Yeah, okay. Well, right. We'll use the 5-point. You say for cosine, if one whole circle is like this, right?
Mhm.
I mean, this is for cosine. Now the 5-point is, let me mention it here. First, we'll check this, 4 pi x minus 1. Let it go to 0, half pi, pi, 3 pi over 2, then finally 2 pi, right? This is the 5-point we want. Then what should be x? Then what should be cosine 4 pi x minus 1? Then finally, what should be y? Then we will get 5 points. X equal to what? Y equal to what? Now let me finish one of them. Yeah, how about I do here? When x equal to, oh no, when 4 pi x minus 1 equal to pi, 4 pi x minus 1 equal to pi, then 4 pi x equal to pi plus 1. Both divide 4 pi, we get x equal to 1/4 plus 1 over 4 pi, right? Yeah, as 4 pi x minus 1 equal to pi, excuse me. So cosine equal to -1, right?
Yeah.
I mean cosine 4 pi x minus 1 equal to -1. Then as this is -1, so of course y is -half, right? Then how about you guys try to finish this? This for Neil, this for Ray. Yeah, and I can mention something. For example, if 4 pi x minus 1 equal to 2 pi, then cosine of this just is 0, right? Then it's undefined, means here is asymptote. Asymptote. Right as this, asymptote. Then same thing for here. If it's yeah, so here also 0. Then again it's asymptote, right? Then you can fill other planets. Yeah, of course this is 1, 0, -1, 0. Then of course here is 1, right? Oh, Ray.
Sorry, I lost my internet connection.
Okay, no problem. You just
Okay, so for this one,
continue to work
I
here.
got wait, let me.
So Neil, for here it's easy to get x. Because 4 pi x minus 1 equal to 0. Then of course x equal to 1 over
Oh,
4
yeah,
pi, right?
yeah.
Mm.
Wait, does that say that says 4 pi x, right?
Yeah, yeah.
Okay.
Then suppose here, you say from here jump 2 steps, increase 1/4. Then 1/4 divided by 2. Then suppose here is 1 over 8 plus 1 over 4 pi, right?
Yeah.
Yeah, you say then this is like 1 over 8, 2 over 8, 3 over
Oh,
8, 4 over 8. Yeah, means half. So they have strong strong rule and logic there, right?
mhm.
Yeah, then calculate what should be y. 0.
Maybe this one is true. It should be 1/2.
Yeah, suppose it's
Yeah.
half. Neil, it's easy get here.
Do you just put like the equation,
Yeah,
like
you say
0
when
into x?
cosine of 4 pi x minus 1 is 1, then it's half, right?
Oh, okay.
Yeah. Then you say it's repeat.
Yeah.
So when you have this 5 point, of course it's easy to get its graph, right?
Yeah.
Yeah.
Yeah, then I will not really spend the time to draw it. Please screenshot this. Are you done?
Yes.
Okay.
Yeah.
Now let's go to 11. Yeah, in order to see the table, we have to let it go kind of small. Oh, come on. Yeah, anyway, table 1 at the bottom shows length of day statistic for Boston over the year 1996. Length of day refer to the number of hours that the sun is above the horizontal. Figure A show a scatter plot based on this data. The number day t of year. What does this mean? Day t, when it's 15, it's about 9 something. Oh, yeah, so it means they are the same thing. One is table, one is graph, right? For example, when here is 180. Why we don't have 180? But anyway, it should be between 15 and suppose need to be more than 15. Is this true? Yeah. Oh, yeah, here not show 180, t equal to this. Just show like 136. Right. Anyway, table 1 and graph A, suppose they provide same information. On the horizontal t-axis, day of the year, January 1 is t equal to 1. Okay, understand it's me. Not as. Find a periodic function of the form y equal to this, whose value approximates the length of day value in table 1. It's like you use sine function simulate this, right? Correct?
Yeah.
Mhm.
The length assume that the period of the function is 366 day, because 96 was a leap year. Okay. We just wanna get A, B, C, D, then we done, right? Now you can know what? Can you decide B? I suppose you can. Yeah, we already know the period. Period is what? is how many days?
Mm.
Here the period is how many days?
It's 366.
Yeah, 366. This equal to what? 2 pi divide who? A, B, C, D. 2y over who? Over A or over B or over C or over D?
I guess over A.
No, over B.
Oh,
Remember sine bx. You say when we add let x go to 2 pi over b, then actually we add 2 pi. It's the signs period, right?
mhm.
Yeah, anyway, it's over b. B affect the period. So we can get b, right? So b equal to pi over 1883, right? We get 1. Then how about a? How you can find a? A means the amplitude equal to what?
Mm.
Any
Seven.
information on
Amplitude.
this? Who can be volunteer? Neil, could you be the volunteer to decide a?
Mm,
Yeah, I remember the formula is this. Amplitude equal to maximum minus minimum, but you need to divide by 2, right?
yeah.
Mm.
Is the max 15? Wait,
Yeah,
no.
maximum you can go to find it or in the table. 15. No, I think maximum is here. Is here.
15, okay.
Yeah,
And the
then where is the
minimum
minimum?
is 9.08.
Yeah. Now we can get it. 15.27 minus divided by 2. Then, yeah, let's calculate it. Divided by 2. So we get, right?
Yeah.
Then what should be C? Oh, no. What should be D? We can decide D first.
Like,
Maybe it's like 9, maybe.
Yeah, who can decide D? Oh, how to
I think
decide D? When you mean it's 9, how you get 9?
See
Anyway,
the starting point, around the starting point.
yeah, remember, yeah, let me draw it. It's a sign, right? It's a sign like this. But if there is D, it go to like, for example, like this, right?
Yeah.
Then the difference between this means D, correct? It's like D unit R, correct?
Mhm.
yeah.
Mm. Then how to get D? Let me give you a hint. Suppose it's the midpoint of maximum and minimum, right?
Yeah.
Okay.
So would it be like, wait.
You said if it's the sign, here is 1, here is -1, its midpoint is 0. That means if it's a standard sign function, then there is no d, or d is 0, right?
Yeah.
But now maximum is here, minimum is here. D still is midpoint. Yeah, anyway, we
Oh,
get d equal to maximum plus minimum, then divided by 2. This called midpoint formula. Yeah, then let's use calculator to get it. Circle is close to 9, but no, circle is close to 12. Right? It's like the average length y of the day, and the circle is close to 12. Right? Like 12-hour, averagely speaking, during a whole year, half of them is daytime, half of them is nighttime. Then half is what? Of course, 12. Yeah, let's calculate it. Divided by 2. Yeah, I get 12.175. So far we already get, let me write it over here. Y equal to A is 3.0 sine B is pi over 183 T minus C plus D. D is, right? Yeah, you can screenshot this. Yeah, let me know when you're done. Then I'll clear some space.
I'm done.
Yeah, in order to decide C.
Yeah, I'm done.
Okay. Now, any idea to get C?
Not that sure.
Ray, do you have any idea?
Maybe input all the other values and then
Yeah,
find
yeah.
C.
Use any point. This just means point. When t, for example, for this, when t is 15, y equal to 9.42, right?
Mhm.
Then the only variable is C. You can decide it. Right?
Yep.
Okay, then we'll not really spend the time to do it. Yeah, just use any point. Normally we choose some easy to go point, right? Like 15, I suppose it's good. Yeah, maybe just use this, or maybe you can use 350. Anyway, try to use some nice number. Okay, let's try to do it. For example, we just use this. So we have equal to sine. Then here go to yeah. Anyway, we have to use calculator. Could you guys try to find C?
Okay.
Yeah, I also use calculator to try to get it.
Would C be
plus this means the psi when psi is negative. Means nice. Anybody get C?
I'm trying?
Yeah, okay, let me write it down. Here is psi, it's about 2575. Yeah, we just use this point, make use minus C plus, right? Then C equal to what?
Um,
Yeah, you'd better round it to hundreds or thousands. Yeah, anyway, what I get is about 1.355. About this. Now let's go to quickly check the answer. This is chapter 8, 11. Chapter 8, yeah, almost. Chapter 8, problem 11. Oh, yeah. Okay, so let's say 3.095. This is correct, right? Here is pi over 183t. This is correct. But this is not correct. 12.087, right? Yeah, kind of different. Then of course this will affect the C, right? Now let's go back. How to get D? Anything wrong? Let's see. We just take this as the maximum value. 14 point. Let me see if there is more information. Yeah, basically we are correct. The number in the top row of table 1 are not as arbitrary as they might first appear. Day of the month. Assume that the period of Yeah, suppose our formula is correct. Like I mentioned, the D is maximum plus minimum. Then divide by 2. That's what we can find. Do I use this? 35 if divided by 2. Yeah, I suppose it's this. Let me see again why I get this. Yeah, there is no explanation. So I don't doubt my method to get this. So I suppose this is okay. We use the right method. Okay, then let's go to next chapter. Any more questions?
Nope.
Nope.
No. Okay, so let's go to chapter 9. Let's see how many. We may not go through each section for chapter 9 and chapter 10. Yeah, so let's see here first. 9.1, this is the basic one. 0.2, 0.3. Yeah, these are basic. The inverse, yeah, even go here. Chapter 9, suppose we'll go through all of them. But chapter 10, right angle, law of sine and cosine, vector. Yeah, for chapter 10, we'll just go through 10.1 and 10.2. Let's try to finish these 2 chapters today. Additional formula. The additional formula for this, you just need to remember. Here, suppose they have the proof how to get it, but we don't have time to go through them. You can check it, how they get it. But we'll just remember the rule and try to use it. Yeah, when you do exercise, you still not remember this. You can go back to check it again and again till it's in your memory. Yeah, but sometimes you can use some special angle to check if it's, I mean this, for example, let's just say 1. Let's just say 1. For example, sine of s plus t. S is an angle, t is another angle, right? Then here we call sine plus cosine. But if you forget, here should be plus or minus, right? Sometimes you just mix them and get confusion. Then maybe you can check one. For example, you just check sine. Half pi. We know this you can take as sine quarter pi plus quarter pi, right? Then suppose it's equal to sine, cosine, cosine, sine, right? They are all quarter pi means sine, cosine, they are the same. Then if it's minus, then suppose equal to 0, right? But we know sine half pi equal to 1. This should equal to 1. So suppose here is not minus, right? The right thing is plus. Do you guys get my point?
Mm-hmm.
I mean, you can use some special angle help you to eliminate the wrong possibility. For example, here it's impossible to be minus. Then what left is plus, right? Yeah, anyway, this helped me to remember this and against some confusion. Then let's go. Example. So first you say here is co plus sine. Then suppose it's related to cosine, right? Then if it's 2 theta plus theta or minus theta, right? Then it's dependent on the formula. Yeah, then what I can remember is cosine 2 theta should equal to cosine theta minus sine theta. Is this true? Then we'll say if theta is 0, then suppose here is cosine 0 minus sine is 0, so it's equal to 1. It's correct, right?
Yeah.
Yeah, but how about if theta is this? Then suppose cosine this equal to 0, right? Then let's check if it's good. Yeah, it's you say when theta is pi over 4, all the cosine and sine they are the same value. So means this minus this equal to 0. So it's true. So suppose here is minus instead of plus, right? Then we get for this should be this we call, so more general, we have the formula. If cosine alpha plus beta should equal to cosine alpha multiply cosine beta minus sine alpha sine beta, right? But here is plus. Then suppose it's another way. Means if here is plus, then here should be minus, right?
Mm-hmm.
So what we should keep here? We should keep the minus. then this just equal to cosine theta, right? So it means after simplify this, it's just equal to cosine theta. Yeah, let's see if it's true. Yeah, you say they have the formula. Yeah, I just mentioned something how to against confusion and error in remember the formula. Yeah, if you want, you can take a screenshot. Are you done?
Yeah.
Yes.
Okay. Yeah, again, if you are afraid of forget this, you can take a photo in your cell phone, right? But yeah, but finally you put this into your memory. Anyway, then how to simplify this? Of course, you use the formula. Yeah, can you guys do this? I can tell you the formula. Cosine. You see here is theta minus another angle pi. So we use cosine s minus t equal to co. Here is minus, here is plus. Sine s sine t. Yeah, you just use this formula. Yeah, how about you working on Leo? Yeah, this is right. To do this, to simplify this. Theta minus pi. Oh, you done?
Yes.
But just because you know the conclusion or you use this formula.
I use the formula. Like because
Okay.
sine.
Yeah, then let's do it together. So cosine, here S just means theta. Then cosine pi, right? Minus sine theta, sine pi. Yeah, we know sine pi is 0. So cosine pi is -1, right? So we get, yeah, we get this. Good. Reduction formula. Confusion identity. So again, use this kind of formula, right? Okay, we'll just then general. Oh, no, not confusion. Here is a co-function identity. Yeah, anyway, that's some basic rule using the cosine of a difference. To find this, yeah, basically we just take 30 degree, 45, 60 degree, 90 degree as a spatial angle. But per this kind of addition rule or difference rule, we can find something even, for example, 15. 15 equal to 45 minus 30, right? Yeah, so we can get the cosine value for 15 degree. Using an additional formula to calculate. Yeah, this time they are not a special angle, but they tell you some trigonometric values. Yeah, as you know sine s, and you know the range for this angle, then you can get something like cosine s, tangent s, and so on. Then you can use the additional formula. Additional formula for tangent. Yeah, so first, you know, there is this kind of a formula. Then after you use it again and again, you remember. Yeah, here how to derive this formula. Using an additional formula for, yeah, so you need to compare this to the formula to see if they are in the form of one side of the formula, right? Compute this. Okay. So let's try some exercise. B, C. Okay, so let's take a break first.
Okay. I'm ready, Captain.
I'm ready.
Okay. How about let's try problem 36. So when you say this, any idea? Do you want to go starting from left side or right side?
Right side.
Yeah, right side.
Right side.
Yeah.
Yeah.
Okay, for me, I would like start from left side. So, okay, oh, sorry, wrong corner. So left side equal to secant. When you secant, just means cosine alpha plus beta, right? Then per the formula, addition formula, it's co. Here is plus, then here is minus, sine alpha, sine beta, right?
Yeah.
Let's say as here has tangent. Then suppose, I mean, both numerator and denominator divide. But anyway, I just means multiply this cosine alpha, cosine beta. Yeah, here also multiply 1 over cosine alpha, cosine beta, right? Then we have, for the denominator, we have 1 minus sine alpha over cosine alpha, so it's tangent alpha. Yeah, it's already matched here. Then for this, 1 over cosine alpha is just a secant alpha. 1 over cosine beta, just secant beta. Then equal to right hand side. Right? Yeah, but the key for step is use this formula. Yeah, let me find the exercise for you guys. Let's go to not so hard. Yeah, how about from the basics? Yeah, how about 11 and 12? Let me write this for Leo, 11, this for Ray. Hmm? Do you guys remember the formula? If not, I can write for you.
Yeah, I don't really remember.
You don't remember, right?
No.
Okay. So first for this, we already write cosine alpha plus beta equal to cosine. Here is plus, then here is minus. Sine alpha, sine beta. All right. Then for sine alpha plus beta. Oh, no. Here is minus beta equal to sine alpha cosine beta minus cosine alpha sine beta. Yeah, so just use it. Oh, sorry, I mute my microphone.
Oh,
Yeah, but anyway, use the formula. Make sure with the trigonometric one you can know for the spatial angles. Do you mean, Ray, do you mean you get answer negative sine theta?
Yes.
Why it's negative?
Wait, wait,
Yeah.
wait a sec. Oh, yeah, it's positive. Yeah.
Yeah, if you find I have mistake, you can let me know. But otherwise, it means I get the right answer, right? Neil, how about you?
I don't really know.
Yeah, let's do it together. Per the formula here, alpha is theta. 3 pi over 2 is the beta, right? So we have
Yeah.
sine theta cosine, right? Minus cosine theta sine. Yeah, just now we already get this equal to 0. This equal to negative 1. So finally we get cosine theta, right?
Yeah.
Okay, please screenshot. Yeah, we don't have so much time spending on exercise. So after class, I would suggest you do enough, either from chapter test or from exercise in each section. Now let's go to here. Next, the double angle formula. Yeah, so this is easy when you have knowledge of section 9.1. Yeah, even we can recover something we write just now. But hold on. Let me scratch some of them. Yeah. Then erase this. Erase this. But yeah, here called double angle. So we can mention one, right? This, like a special case for this. Just let alpha equal to beta, just equal to theta, right? Then we have cosine 2 theta equal to cosine theta times cosine, then cosine theta square, minus sine theta, so sine theta square, right? So it's a special case for this general formula. Yeah, then even we can use this to derive formula 1. How? Just let alpha equal to theta, but beta equal to negative theta, right? Then we have, yeah, per the formula here. Then we have sine theta minus negative theta, so just 2 theta, equal to sine theta cosine negative theta minus cosine theta sine negative theta. All right. Cosine is an even function, so cosine negative theta just theta. So it's sine theta cosine theta minus cosine theta. Sine is an odd function, so sine negative theta equal to negative sine theta. So then it means double of this. So go to here. Yeah, anyway, you can derive all of this from formula in section 9.1. Yeah, if you want, you can screenshot this because here shows some logic for the formula in these two sections, right? And for tangent, you can get from here. Right, so this over this just means tangent. Tangent to theta. So it means this over this. Then you do some simplify. 2 netted just has tangent. Okay, then we just make use of this. Oh. Sine theta equals double angle formula. Okay, let's say example 3. As here is 3 theta, you can just split it into 2 theta and another theta, right? So use the formula cosine, cosine minus sine, sine. Then keep going, cosine theta equal to this, sine 2 theta equal to this. Then anyway, finally get this. Equivalent form of the formula. Yeah, here do some conversion. For example, we know. Oh, hold. Yeah, for here. We know sine. We have sine theta square plus cosine theta square equal to 1, right? Then you can eliminate either sine theta or cosine theta to get this. Then from this, you can derive to get formula 3. Right? From this, you can get formula 4. The power of yeah, here let the high power of cosine t go to multiple angles, means 2 of t, 4 of t. Yeah, let's see how they do it. So first, let it go to cosine t square, then square. Then cosine t square is this. Then do some algebraic conversion. And for this, you can keep going. Let it go to relative to cosine 4t, right? Because the 4t is double of 2t. You can use formula again. Yeah, I know there are too many formulas here. You have to spend some time to practice, which help you remember the formula well. by the way. Yeah. The half angle formula for this. By the way, how they get this? I suppose it's just from this one. For example, let's derive one. Yeah, if we do a change, we call this is let me. Yeah, if we call in this formula, if we call 2 theta is, we can just call it t. Then theta is half t, right? So we have cosine half t square equal to cosine t, right? Then even we can take square root. Then as cosine half t has a chance either positive or negative, so you should add this, right? It not means it will be both positive and negative. It means in some cases it's positive, some cases it's negative. It's really depend. T over 2 is in which quantity, right? Anyway, so this is this half angle formula actually from here. Yeah, let's go to there. So I derive the cosine half of s equal to this, right? Just replace replace t by s, then we get this. Then same thing to get formula 1 and 3 here. Yeah, it's kind of tricky.
How did you remember all these formulas?
Oh yeah. You'd better too.
Yeah, but how?
Some example, maybe they tell you the formula, but if in the case they don't tell you, then how you can solve problem? So to play safe, you have to work hard to remember them. But there are not of logicals between them among all these formulas, right? Even sometimes I forget them, or I have to use some logic to recover all of them. Anyway. Yeah, but we don't need to worry too about on this. We just make sure we understand why we have this kind of formula, why they are true, and know how to use them. Now let's say evaluate cosine using a half angle formula. Yeah, let's think about it. So this is a half angle, or this is a whole angle. If this is a whole angle, its half is just this, 52.5. It's even not nice, right? Then suppose maybe this is what we call half angle. So its double is 210. 210, you can let it go to like AD plus 30, right? So we have a chance to get either cosine or sine of 210 degree. Yeah, anyway, we will not spend so much time on this. We will just quickly look at it. Get this. Then, how they get this? Using the formula with... Anyway, you have a way to get cosine of 210 degree. Then you can get cosine of this. Prove that theta, tangent theta equal to this. So I suppose it's not so hard. You just let sine 2 theta go to expression of sine theta and cosine theta, and also for cosine 2 theta. Then, property summary. There are so many property and formulas, right? Yeah, but good thing is it's all in one. Now let's do a little bit of exercise. Ray, could you pick a problem from this? Ideally, it's like a odd number problem.
Uh, why don't we do 39?
39. Okay. What should we do? Prove the given equation are identity. 39. Okay. Oh, come on. What's your idea? You want to go from left, start from left, finally reach right.
Let's do from left. I think
From
that's a
left.
little bit easier.
Yeah. Okay. So let's think it together. Left side equal to sine theta square then square, right? Then what's next?
郑总，你跟老师说你下来1分钟。跟老师说。
老师，我有点事，我先这个下去1分钟。
好的，没事儿，no problem. Yeah, we have the formula sine theta square equal to 1 minus cosine double theta square. Then we'll use 4 1 minus 2 cosine 2 theta. Oh, let me see. Sine theta square, yeah. Make sure here is 2 theta, yeah. Then plus cosine 2 theta square, right? Then keep going. We have keep this 1 minus 2 cosine 2 theta, yeah. Then again use the formula. If we take 2 theta as an angle, so this will go to plus 2 1 plus cosine 2 theta double, then it's 4 theta. Yeah, let me say. Should I take square? Yeah, I need to take square. Oh, hold. Sine theta square equal to this. This go to 4. This is 1 minus 2 cosine 2 theta plus cosine 2 theta square. Oh, here don't have square. Yeah. So just means this go to this per the formula. Yeah, here 4 theta is double of 2 theta. Okay, if so, we can get both multiply 2. This multiply 2. This also multiply 2. So we get 8. 1 minus 4 cosine 2 theta. Plus 2 plus 2 cosine 4 theta. Oh, no, something wrong. Something wrong. 2 and 2 cancel. Here is 1. Oh, here should be 2. Sorry. Here should be 2 because 2 times 1. Here should be 2. Then here is 1 plus cosine 4 theta. Then combine 1 and 3. 1 and 2 will get 3. Then this means they right. Okay, we have to go next. The product to sum and sum to product. So this chapter is kind of a challenge. Why? Too many formulas, right? And they are non-formula. Yeah, so how we get this? Here show something. Just the cosine A minus B, cosine A plus B. Per the addition or subtraction formula, you get this. Then you do some, it's like solve equation, right? A solve system equation. For example, if you want this, then you try to eliminate this, right? Then you get this. Change your product. Then we see what happens. This is like a product of sine function. Now we need to go to the difference of its addition angle or subtraction angle. Yeah, if you want, even you can take a screenshot. No, not screenshot. I mean, you can use your smartphone, take a photo of this. So in the beginning, help you at least know this formula.
Yeah, I'm done.
Okay. Use a formula for sine A to simplify the expression of this. Yeah, remember, actually we'll get two angles. One is A plus B. If we call this is A, this is B. One is one is, or we call this B, because B is bigger, right? B plus A. Another is B minus A, right? B plus A is 90 degree. B minus A is 6 degree. Both of them are spatial angle. Yeah, anyway, here show you just use the formula. Then find change product to sum of this time for cosine. The sum to product. Okay, again, you can take a photo for this. Okay,
So
you
this
done?
is so this is for two separate sine
Yeah.
functions.
Yeah,
right?
so sum, you can also call this sum, right? The sine alpha and the negative sine beta. Yeah, anyway, then right side is product. It's just the another version for this formula, right? You say, for example, if we cosine, yeah, if we solve this system equation, equation 1 and equation 2, then you can get a cosine of A minus B equal to bottom. Cosine of A plus B equal to bottom. All right, like this. But now you call this is, when this is alpha, this is beta. Then A and B. Yeah, that means we have A minus B equal to alpha. A plus B equal to beta, right? Then A equal to alpha plus beta divided by 2. Then, of course, you can also get B. Yeah, they are tightly related, but in different form. Yeah, we will not talk too much on this. Yeah, let's try to do one. Yeah, Neil, how about this time you pick a odd number problem?
45, I don't know.
45. Let's say. Yeah, even I suppose this is the most challenging chapter for trigonometric functions. Derive the sum to product formula for this. Hint, in the formula for this, which we derive, replace each occurrence of beta. Sum to product. So, yeah, again, let's suppose how to do this? Let me see. If we call alpha is A and B. Sine the product. Yeah, anyway, if we suppose alpha equal to A plus B, yeah, let me try beta equal to A minus B, right? Then we'll get A, let me write a little bit on top. A equal to alpha plus beta divided by 2, right? Then B, yeah, this is B, not beta. B equal to alpha minus beta over 2, right? Now let's say sine alpha. Derive the sum of. Anyway, let me say sine alpha means sine A plus B minus sine beta, that means A minus B, right? For the formula here is for sine is sine A cosine B minus cosine A sine B. Yeah, anyway, this is the first one. Minus sine A cosine B plus cosine A sine B. All right. Then let's see which one can cancel. Sine A cosine B, sine this cancel. So we get negative 2 cosine A sine B, right? Then this means negative 2. Who is cosine A? It means cosine alpha plus beta over 2. Multiply sine alpha minus beta, right? Yeah, anyway, this is a basic way to do it. Now, 9.4. We still have 9.5. Trigonometric equation. Some of them just easy, but it can also be very difficult, especially consider about the periodical. So the solution normally is not just one. Suppose you need to add like 2k pi or k pi if for tangent, right? So sometimes they just let us find all solution during one interval, for example, 0 to 2 pi. Yeah, anyway, let's quickly go through it. Yeah, so for this, you see this looks like simple. But suppose there are infinity many solutions. Anyway, let's say. You see when happen at these two places, the sine equal to half, right? Then, yeah, don't forget to add the 2k pi. There are 2 places. Then each of them add 2k pi. Inverse cosine, inverse sine, inverse tangent. And don't forget the interval for this. Like it's range, right? It's a range for this inverse function. Okay, for this, solve quadratic equation first to get cosine. And make sure cosine should within -1 and 1. So this doesn't make sense. This need to be disregarded. Again, solve algebraic equation, get tangent. Then find the value in the specific interval. Yeah, for example, let's talk about this. Tangent theta equal to -3. Yeah, this page, this screen still not show what is the value for this theta. Who has idea? You can use calculator. First, get theta equal to what? Could you use calculator to get theta when tangent theta equal to
I
-3?
thought -71.
Could you write on the screen?
Okay.
Let me see. Negative. This means degree.
Yeah, it's degree.
Yeah,
Gene.
we wanna in reading layer.
Okay, okay.
So
It's,
-3, negative tangent. How you get?
wait a second.
Oh yeah.
Do we need to all
Yeah, but we
parts
wanna
of-
answer in this 0 to 2 pi, right?
Uh-huh.
Then how you can get this? You just add the pi. So what we
Yes.
want is pi minus this, right?
Uh-huh.
Then 2 pi minus this, right?
Mm-hmm.
Then it's the one we want. Yeah, let's say this. Then plus pi get this. Plus 2 pi get this. Okay, yeah. So this is also hard, right? Anyway, when you have this, so we use quickly get this. Let there just has tangent x, right? Then solve it, find the tangent x. Then again, what do we want to find here? Here, uh, here don't mention the interval, so you need to find all solutions. So add the k, which means any integer. Square both sides to solve. So find 3x first, then divide by 3. Transform my equation in order to use use a double angle formula, right? Sine 2x equal to 2. But we know sine, the range for sine is always within -1 and 1. So this is impossible. So no solution. Yeah, here you can use a tangent. Okay. Yeah, we can do one more exercise. Ray, could you pick one before we end today's class?
Let's do let me see.
Okay, so sorry, I changed mine. Maybe we can go through the last section about the inverse function.
Oh, okay.
Yeah, the inverse trigonometric function. But actually, we already deal with lot of inverse trigonometric function, right? Even from last chapter. Remember, for sine of x, there is no inverse function. Only you just take one interval, you can have inverse function. Yeah, like here. Yeah, and remember we always include the interval most useful, right? That means that from 0 to half pi. We'll always include this, right? Another is we'll always guarantee it's one-to-one function. So for sine, we take this. Negative half pi to half pi. For cosine, yeah, when we go to cosine, here for sine, yeah, when we go to cosine, where is cosine? No cosine. Oh, cosine is here. Yeah, anyway, this time they show we take, which include 0 to half pi, then keep going here till to pi. We cannot use this, then it's not one-to-one, right? If we use this, it's not one-to-one. Compute each of the following. So first, for part A, when you get this, definitely it's within 0 to pi, right? So again, this is an angle within 0 to pi. Then you take cosine. Tangent. Yeah, here talk about the tangent. So we use negative half pi to pi. Find its inverse function. They are symmetrical about y equal to x. Yeah, so you exchange the domain and range, right? Yeah, then chapters. Okay, so we have to stop here. We don't have enough time for exercise. So for your exercise, you still do the chapter test. Review exercise. Okay. Yeah, chapter test. Make sure you go through all of them. Each of them, I suppose, represent a knowledge point, right? Yeah. Sorry, we have a huge content here. Okay, I'll see you guys next time.
Okay,
Okay.
thank you.
Yeah,
Thank
I
you,
want to
goodbye.
cover chapter 10, but we really don't have enough time. Okay, see you guys
Okay.
Thursday. Bye.
Yeah.
Bye.